Hi students. In the last lecture, you have learned how can I implement a queue using a circular list. The basic idea of a circular list is that you have to reuse the last null pointer. So rather than just marking as a null, you can point it to the first node. From that setting, it is easy to insert at the end of the linked list. So you can easily implement the queue because you can easily put something at the end. And furthermore, the first element can be accessible from the link from the last node. So the queue can be easily implementable. So instead of pointing to the null, so you can mark it to the first. Okay, so you can make a circular list. So you can insert easily if it just checking the last node is null, then you just setting a special setting for that. If it is not, then the last element is pointing an actual node, then you can link a new node to the next of the last node. Okay, so you can make it insert here. And for delete, you have to check the queue is empty. If the last is null, then queue is empty. If it is not, you just delete the last element, the first element. So you will find the first element here. The next of the last is the first element, and you will save the temporary data. So you can just switch this temp data is the first data. So you can make this as a third statement. And you just dequeue it, just remove it from the list. So last and next will be set the first and next, and delete the first and return temp data. So in this way, you can make a circular list. And today's problem is to make a queue as an application of this queue. But let's think about that. How can you implement a queue empty? What is the operation of queue empty? Then maybe report an error and just terminating the current execution. But then maybe continue the current execution with an error message. Okay, so in an interactive session, you may want to just report an error and try it again or something. Or in a batch mode, you can respond. Your program can respond error message and terminate the current session. So you have two choices depending on the uses of your queue. So it depends on your master program, which is using your data structure. So in that situation, make a certain action is not appropriate. So just to report the problem and you are waiting, the appropriate responses can be adopted from your host code, which is using your circular queue. So in that way, so that means the 2 points are different. So that then may be implemented using exception handling. The key of the exception handling is that the error detection point may be far away from the handling point. So your host program may handle differently on the certain erroneous condition. So that is the rationale of exception handling. So let me show you another example, which can be more practical. So think of that you have a little brother, younger brother, and you want to ask him, hey, please bring me a Coke from the supermarket. and you you surely give him a certain money, and he's going to the supermarket, but it happened to be there's no Coke in the market. So he just found an error. You need a Coke, but he found it is not. So how can he do what he can do at that point? At first, he may decide that, oh, my elder brother may want to Sprite instead, so he may bring Sprite, but you maybe get annoyed for that. So the best way is to calling you, hey, there's no Coke. Then you can decide, then please bring another soda. Or you may decide that please search for nearest other market. So it depends on you. And your your younger brother is just detecting the problem, and you may decide from the distant away, and you may decide handle it differently. So that is why um, we are using the exception handling. So let's take a look on exception handling here. An exception denotes an error which is detectable. The concept of an exception is very simple. It is just a detectable error. For instance, if you try to pop an element from an empty stack, that is an error because the stack is empty. So you cannot get a data from that stack. So that is an exception. And an exception can be handled in C++ using try-catch. So catch is generally used in C++ and Java, but raising an exception is different. In C++, they use a keyword throw. So throw an exception and you catch it. So they have different concept. For example, the following code shows a counter throwing an exception. This is a very simple problem. So you just make a counter here, counter 5. So it is initialized 5, but the operation of the counter is counting down. So you are making a decrement operator in postfix. So it is decrementing the counter, and you're just printing the output to the cout. Okay, but what happened? It goes under 0, so it get minus. Then it may be forced. It may be not good for your case. So in that case, you may throw an exception. So here you make a throw here, throw -1. This will be throw an exception. But so if you look at this operation, it is much like that. An error is just called from that erroneous case. So that is simply same to here. So you will take QEMP here. You will take a QEMP. How can I do that? Select this one. So you'll take a QEMP here. So that is similar to make an exception in the queue. So let me switch to the previous problem. So you just make an error which will throw -1 as an exception. So let me just then that exception may be caught from this catch. So you are trying something, an exception raises, and you catch it. And your code exception is integer exception, so you are specifying the type of an exception. That is another slight difference of C and of C++ and Java. in Java, the exception should be a certain type, which is a subclass of which is a type of exception. But in C++, you can use arbitrary type. Here you use the -1, and that exception can be caught by your host program. So let me try this. Let's just save this. And let me try to substitute. I'll try it from where is MSys as an actual code. So let me reshare this screen. So you can find the same code in the terminal. So I declared a class counter. It has a private member variable underscore count, and it is initialized in the constructor. And your operator minus is defined here. So you may be wonder why int is needed here. So you may be wonder. Can you find the reason why int is needed here? The reason for that, making an additional parameter as an unary decrement operator is that it can make it as a postfix operation. So without this, that means prefix. So if you write operator minus without an argument, this is for prefix, and this is for postfix operator. Okay. So since I used a postfix, so I overloaded the operator in postfix. So if the counter is negative, then error. Just call an error. And if it is not, it is returning the correct counter, and the counter is decremented. And error is throwing the -1 as an exception. And your main function is make a counter 5. So while it is true, you are printing the counter and decrement it. Okay, so once it raises an exception, negative counter is printed to C error. So you know the C error is different to the C out, and returning -1, which means that it is an error. So let me just check to compile it, make counter, and executing counter.exe will show you 5, 4, 3, 2, 1, 0, and boom, negative counter. So counter.cpp, in counter.cpp, you may decide that the error value is not counted here. So you can catch the error value as a number, and just return the error as a value. So you may wonder, this is somewhat meaningless sometimes, but it is actually meaningful. So make counter, and the execution result may be same, counter.exe. So you may define that result equal 1, then you may echo the result 1. Okay, so you can set the result as is set as the resulting value of current counter.exe. So you please use the backport. That means execute it, and the result is caught by the result. What's wrong? So there's no standard error, but you may check that You may check the echo result. Oh, actual result is saved here. So actual result is saved here. But where can I check the -1? I cannot do that here. So anyway, you can once once it runs correctly, you may combine them. So counter the exe. If it is successful, you may try another counter that exe. But you know that it is executed just once because the first one is not successful. So you may counter the CPP, check it. And rather than returning error, you may return 0. So that means this means successful. The execution is successful. Then you can make counter. And you can combine execute the counter.exe as the first execution command. If it is successful, execute it again. So you may try this. So can you see it is executed twice because of the return value. So the return value is actually used in the Unix environment. So that is also possible, I think, in Windows. At first, it was not, but they slowly moved to Unix. So anyway, so counter.exe, counter CPP, you can raise an exception, and then exception value can be used, or can be used here, where it may be neglected. So using underscore is a good idea for neglecting it. So this is not successful, so I erase this. And another important point is that what if the counter is initially minus, then you may raise an exception, or just try this, try another thing. So is this really important? If you want to check it first, so let's make a Boolean function. Is negative you can make is negative Boolean function, which is returning the counter CNT is negative, then it is true. So in that case, you may want to check it if counter is negative is not true. So if it is positive, so while it is not negative, you can keep going to count it. So if you make this, then you can check it to the exe, and the return value should be 0. So it can be successfully combined. Counter the exe and counter the exe. Okay, so it is truly terminating correctly. So this is another way to handle an exception. So this is a C-like way. Rather than throwing an exception, you may check the condition a priori. So you may check the condition a priori. Then you can it is not needed to make an exception handling. So you may think that, but it is inevitable. What if the counter is initially -5? Then this is not executed at all. So you can make a counter and counter the exe. So it terminates fine, but you may think that it should be checked by your program. So your program check that negative counter should be reported in your code. So you may think about that. So in that way, you have to raise another exception in your constructor. So in your constructor, you may if n is negative, then you may throw -1 or -2, anything will do. Or just call an error. This is another way to throw an exception. So in that case, you have to make a try at here, try and that should be caught here, catch negative counter. And in this way, in this case, this may be copied here. But you have to indent all these to make it readable. Okay. So in that case, you can handle an exception. Make counter negative counter is caught correctly. So if the outermost one, so this indentation may be cumbersome in some cases. So if the outermost one is the try catch, so you can try that without indenting them. You can make it. You can make the whole block of a function as try catch. So this is valid. You may wonder, is this possible? Yes, this is truly possible. So if your code consists of a whole try block, if your function block is a whole try catch block, then you may try that. Or more readable way, you may want to try catch as a main function block. So this is not needed. Okay. So you can make it. Yes, it is possible. Negative counter. So if it is not negative, so counter the CPT. So let me just make it read an integer n, maybe initialize 0, and you want to read it from Cin, and you want to initialize it the counter as n. Okay, so make counter. So if you try counter exe and you want to counting 3 to 1 0, it terminates correctly. So counter.exe, if you try -2 and negative counter. So this is a more good way to show the erroneous case and the normal case is separated. Okay. Any questions up to here? So I'll switch it to your previous handout. So the trailers here, note that the exceptional value can be arbitrary type in C++ in the above code. The value is ignored but you may use it. So I always used the error code here as a return value. You can also rewrite the above code to throw an exception in the constructor. So I tried that. calling error in the constructor. Actually, the above code can be rewritten using a predicate method such as is negative or done. So even if the predicates are used, the exception raised from the constructor is inevitable. So the try-catch is still needed to handle such a case. Such a case is when you're creating an object, then you can find an exceptional case. Okay. Okay, good. So if you don't have any question up to here, I'll explain today's problem. Today's problem is airplane. So two sets of planes are waiting in two lanes merged into a single runway to take off. So you may imagine that the two lanes are merged. So they are waiting in a queue in the first lane and the second lane here. And they are the two lanes. So you may think about that. Two lanes are merged in this way. In the airport. Okay, so you have to, the airplane should take off from here. The airplanes, sorry for the bad figure. So they want to take off from this runway, but every airplane has a unique positive precedence value ranging from 1 to million. So the control tower wants to, here's the control tower. Control tower wants to allow a plane to use runway to take off one by one from each lane because they should not be crashed. So from the first lane in two lanes, first place, you just think about the first planes here, 12 and 14. And you know that the precedence of the second lane is higher than the first lane. So you have to select 14. So as a director of a control tower, you want to find the sequence of a plane to take off. So you want to take off 14 first. 14. And then they should be removed. And you should compare 12 and 3. Which one is higher? 12. So 12 should take off. And it should be removed from here. And 6 and 3, which one is higher? 6 should be removed. And 3 and 5, which one is higher? So in this way, you have to determine this order of takeoff. So let me show this. In a result. So as a result, you have to think about from the 14 and 12, and 14 is selected, so it should be removed. And you have to check 12 and 3, and 12 is the highest precedence, higher precedence, and printed and removed. And how about 3 and 6? 6 has higher precedence. 6 should be in the entry and removed from here. 5, 3, 5 is higher, removed from here. 3, 2, 3 is higher, so removed from here. And 22 and 2, 22 is higher, removed from here. 17 and 2, 17 is higher, removed from here. 8 and 2, 8 is higher, removed from here. And 2, nothing, so 2 should take off, and 10 should take off. Okay, so you have to maintain the values of a plane, each lane with a Q. So you have to maintain a QA for this, QB for this, And the final sequence should be maintained another Q. QC can be maintained for the runway. So therefore you need 3 Qs in total. So assume that the number of planes in each lane is the same. So there's a 5 airplanes here, 5 airplanes here. And assume also that the precedence values of the planes are all different. So if some precedence value is 10, there's no other planes with a precedence value of 10. Okay? So your program should read from standard input. The first line of the input contains a positive integer n. So in this case, 5. And a number of airplanes in each lane. And the ith line of the following n lines of the input contains 2 precedence values of AI and BI, the precedence values of the airplanes in each lane. The i's range from 1 to n. So 2 precedence values of a line are separated by 1 or more spaces. So sometimes it is separated by 1, sometimes it is separated by 2. So this is the same case of the example case in the problem. So you may check it just for sure. And your program should print the resulting sequence 1 by 1 per line. Okay? So you don't have to worry about the trailing spaces as an output. So in the second case, 2 airplanes per lane. So 19, 10, 8, 29. So comparing 19 and 10, 19 should be dequeued. And 10 and 8, and 10 should be dequeued. 8 and 29, 29 should be dequeued. And the left one, and the remaining one is 8, should be dequeued. Okay, so this is your final sequence. So do you have any questions on today's problem? No questions? Then you have about 30 minutes to go in class. And I'll check for lay students. Dang that fun. Mustafa Ali is just asking. You should implement everything. Using a circular queue. Using 3 circular queues. Yeah, circular linked list. 우체 자미안 퓨랩 attended. 이강인 attended. 한혜린 attended. So you're late today. 이도연 attended. 최가연, 김혜린, 김재영, 김태훈, 정현우, 이채로. So as an additional requirement for bonus point, you may either use exception handling or you may implement isEmpty predicate. So the predicate means, here predicate means is just a Boolean function. So it is a jargon from the logic domain. So the predicate is just a Boolean function. Boolean function. Which means that your method should return bool is empty. (8 p.m. please). So if you don't have any question, see you on next Monday, and there will be no class on next Monday, but I'll see you on the classroom, and the details of the room and the time will be posted again. Okay? So thank you all for joining this lecture, and see you next time. Bye bye. 수고하셨습니다.